Why do students struggle in mathematics? These are just some overarching characteristics of what the research tells us why students aren't doing well. So, of course, that working memory, they're having to store it all. I always compare it to reading. We want kids to have that sight word to increase their fluency. Well, the same thing with mathematics. They need to understand the value of the number and the digits within the number and not have to store all that. All of a sudden, second and third grade, when they start seeing multi-step problems and they're going around and they're like, oh my gosh, everyone else is done and I'm still here, I must be done, because their working memory is in overload. I often tell teachers when kids go home and they're like, my brain's hurting, it's because their brain is tired. They have so much because of that weakness in their working memory. And it often stems because of a lack of that basic early numeracy. And that's something as a nation, we often, we want to speed up and let's throw it in an equation, let's solve facts. But do kids even understand the numbers? How do we break apart numbers and that decomposition and the time spent? The other big piece is symbols. I've done a lot of work, especially in kindergarten and first grade, with the equal sign. I've gone into high schools, middle schools. If you ask a student what an equal sign means, they usually say the answer. And I've seen kids where I've written like 5 = 3 + 2, and they're like, Miss, you wrote it wrong, because like the answer has to go at the end. And even working in early elementary, the idea of decomposing numbers. Well, 3 + 2 = 4 + 1. That's balancing equations. And you can do that as early as kindergarten, as first grade, and understanding that equal means the same as versus the answer. Every single middle school and high school teacher would love it if their elementary students came to them. But think about all the other symbols that we use. An X means multiplication. Oh, not anymore. Now an X means variable. But now we're throwing in parentheses. And we throw in a lot of symbols and just think that osmosis, kids pick it up. And they often need to be explicitly taught those, especially our kiddos that struggle. And I'm saying struggling very broad, so meaning kids in special ed, on 504 plans, at risk, receiving some kind of tiered intervention. So when I say math difficulties or struggling students, it's encompassing all of those. Going into the whole number computations, basic facts. Again, I'm working at a middle school right now, and that's the biggest complaint from the teachers is like, in 8th grade, why am I still working on facts? They don't even know their basic facts. And then they can't apply that to ratios and fractions. And again, those higher level pieces. I often use the example, a pair of pants. First, I start with a pair of shoes. Well, that's 2. Or if I say a pair, that's often 2. And then we say a pair of pants. Well, that's only 1. Or the word table. We eat lunch at a table. I've asked you to make a tea table. Oh, and then we use a multiplication table. And they all look very different. And just thinking about all the words we use in math that we often don't explicitly teach. And we throw them out. Oh, it's an improper fraction. And yet you go and the kid's like, I don't know, the number on top is bigger. They have no clue what it is. And that's that vocabulary. And again, that language piece. And then word problem solving. A lot of teachers are nervous to teach this. We know kids that are weak in math are often weak in reading. And so it involves reading. There's also so many teachers teaching keywords instead of schematics. It's a misconception, and it further often hinders those students. And then that self-regulation, which kind of goes with the idea of executive functioning, knowing what steps and what algorithm or what strategies to be using. Is there a picture I can always lean into? And so when we think about, that's a lot of pieces. And as the students get older, that gap widens because they do lack a lot of those early foundational skills that they need to apply in the higher level. And so if we just think about how is this all connected, we need strong foundational numeracy skills, which means our K, 1, 2, even 3, 4, and 5, they need to be strong in math. Many teachers, when I've worked with elementary, that's one thing that they don't necessarily feel strong in. I know some elementary schools are kind of playing with departments so that you do have someone that kind of becomes a master of math. But again, there's quite a bit that, but if I lose a math teacher, it's not just I have to find a 4th grade, I need to find a 4th grade math teacher. And it becomes just another challenge when we're thinking about teachers. And then of course we have those critical middle school math concepts, ratios, proportional reasoning, fractions, that we know has to get to that high school algebra. Algebra is that gateway. We know that if students are successful in algebra, they will be successful in most post-secondary as well as those higher level math classes. But what's happening is that kids are barely passing algebra and then they are going to a community college, going to a university and having to take prerequisite skills because they don't have the math needed to be successful at that higher level. What does current instruction look like? We know the deficits, but what does it actually look like? How are your math teachers prepared? How many classes do they take that address students with math difficulties? How are our special ed teachers prepared? How many math classes do they take? Thinking about not just special ed strategies, but how to actually instruct. There's a lot of schools that are trying to implement MTSS well and hiring interventionists. And so thinking about, are there certifications that your state has started playing with or even talking about for these, like a math interventionist, sort of like how we've had reading specialists in the past? So what should instruction look like? These are just practice guides that I pulled out. This first one is specific to algebra knowledge in middle and high school. So this idea of using solved problems to engage students. I've been working with middle school teachers and we've been really trying to increase this because we know students that struggle when they look at that problem, they're like, it's overwhelming versus, hey, what happened? Who do you agree with? I have student A and student B. It takes the pressure. They don't have to solve it. They just have to analyze what someone else did. The teachers have found discussion and students having much more confidence when they start using those solved problems. The idea of utilizing the structure of algebraic representations, intentionally choosing from alternative algebraic strategies. So again, thinking through and developing that conceptual understanding. I'm just summarizing a few. These are, of course, are all free. This practice guide came out 2008 or 9, and so it's a little bit older, but it still very much holds true. And so this was probably one of the first ones in mathematics. So just the idea of using explicit and systematic instruction, and yes, that can be used in core, and yes, you can still have high classroom discourse with explicit instruction, solving word problems that's based on that underlying structure, opportunity for students to work with concrete and visual representations. So we often call that the multiple representations, the CRA, motivational strategies. And I will say as students get older, we see less and less manipulative. We know that there's these evidence-based practices. We know we should be doing this, but is it effective? I think most of you are joining because you know it's not effective. So the most recent NAEP scores, so again, this was from 2017, math scores are pretty stagnant. They are not doing much. And this is for overarching, so all students. But we're not seeing huge growth. And I think it often comes down to that conceptual piece. There is a grade 12, but I focused on that 4 and 8, knowing that those are the skills that students, if they're not doing well at 4th and 8th grade, they're not going to do well in 12th grade. And then if you go to the next slide, we see our students in special education. And so the top chunk, students with disabilities, and then students without disabilities, they are really not doing well. Again, we know they're in special ed for a reason. I've talked to teachers, but how do we have high expectations and really teach them those conceptual understandings so that they can be successful? So this is 4th grade. The next slide is 8th grade. This 8th grade is actually a little bit sadder. It is a very low percentage. Why are students not making the desired outcomes? Ineffective instruction, not having their own confidence, not enough practice before they go out. And so the National Center for Intensive Intervention helped create some awesome modules. We are consistently trying to put out quite a bit of resources on there.
I did some work with CAT's organization, the National Center for Intensive Intervention, and we made a set of resources related to teaching math to kids with learning difficulties. And I think the first thing is always, how do you find this? And so I wanted to just show you how easy it is to find these resources. So I'm on Google. If you just go to either NCII, which is the National Center for Intensive Intervention, and you type on math course, the first hit that comes up is the math course, all right? You can also type in intensive intervention and math course, and it will come up. We worked on developing a course related to intensive intervention and math. And I think for some of you who are teaching math methods courses, I'm really excited to share this with you because this was designed with people like me and you in mind, so that not only can educators and schools access this information, but instructors and faculty can use this to design their course content. This course here, if you scroll down, it has 8 separate modules. So this idea is that this is really an introduction to intensive intervention and math. And so module 1 is an introduction. So, why is intensive intervention and math important? It's a lot of the things that Kat's already been talking about today. We talk about how to think about the scope and sequence for students. When we have students that are grade levels behind in mathematics, what's essential is that kind of like numbers and operations strand that leads to algebra. And module 2 here is about doing assessment within intensive intervention. And then modules 3, 4, 5, and 6, and 7, all about instruction. And then module 8 puts it together. So here's an example, module 2. This is all about assessment and progress monitoring. At the very top where it says module overview, this is what I think a lot of you will be very interested in. So here is a complete slide deck. It's a PowerPoint presentation. So you can download that and use 4 of those slides in your teaching, or if you want to use all 100 and some slides in your teaching, you're welcome to do that. It's basically like what I, Sarah, would use to teach people about progress monitoring in math. And then we also created this workbook. It's a PDF, as you can see here. These are all the activities that we go over in this this module. So these would be great, like in-class activities. Some of these are good out-of-class activities. Like one of the activities here is for people to go to their school and do an assessment of like, what are all the assessments available at my school, right? So that's something that your pre-service teachers could do, your in-service teachers, or any teachers that you're working with like statewide and doing coaching. This module overview and these materials up here, these are really for like you to deliver to other persons. If you don't want to do that, or if you don't have time to do that, then we have video recorded all of this content. So there's an introduction. This is always just a few minutes long. That's kind of like what's in module 2. And then every module has 3 parts. So you can see like, here's the title of this part. So here we talk about what are different types of assessments in math. We get into formative assessments, summative assessments, and diagnostic assessments. Here's some activities that you do along with this video. And what a lot of people are talking about is doing this in kind of like a flipped classroom thing. So let's say, you know, perhaps you're teaching math methods and they might be like, okay, watch this 20-minute video and then let's do this activity in class, right? And so there's a lot of different ways that you can use this content. Part 2 of this module is about progress monitoring measures, which is really essential within intensive intervention. Here's some video examples here of students actually taking these different types of measures, and then you can score in real time to really understand, how do I score number identification, quantity discrimination, and that type of thing. And then down here at the end of module 2 is how do you interpret these progress monitoring scores? So you graph this data and then what do you do with it? So we talk about setting goals and decision making. And so the idea with this course is that it sets up people with a good foundation in intensive intervention. I will go ahead and say that not every single thing that a person needs to do in an intensive intervention is in here. It's a limited course, right? But it's a really good, like, hey, let's get this started. Module 2, which I just showed you, is about assessment. Module 3 is all about what's an evidence-based intervention, how is that different from an evidence-based strategy, and where do I find those in math? Okay, so kind of like surveying what's available for you to use in math and what does research-based actually mean. Module 4 is really all about explicit instruction, as Kat was talking about earlier, CRA, or multiple representations, and important use of math language. And so the 3 parts there address those. Module 5 are 3 strategies that really seem essential to embed within intensive intervention in math. The first is fact fluency building, and I know, Kat, you talked about that in middle school. That's our exact experience as well. So how do I build fact fluency with kids with learning difficulties? Module 5, part 2 is my favorite thing in the world, word problem solving. The video is almost an hour long, but if you ever wanted to know anything about word problem schemas, that's your video right there. But again, you can watch the video, have your students watch the video, or you can take my presentation and deliver it yourself. Like, we kind of designed it so it can be used both ways. And then we also talk about a motivational component. But I'm really happy with modules 6 and 7. These are really not how to teach. This is important knowledge for you, the teacher, to know. So module 6 is all about really the concepts behind all whole numbers. So what does it mean to add, subtract, multiply, and divide? And then it gets into some procedural stuff there as well. Module 7 is all for teacher knowledge, boosting your understanding of fractions. And so we focus on the set model, the area model, and the length model of fractions, and talk about how to do that conceptually and procedurally. Module 8 is about implementing with fidelity, which I think is a really important thing if we're choosing any evidence-based intervention to do. Part 2 here is a really important one within intensive intervention. It's about how do you make adaptations to your math instructional program. And then module 8, part 3, it's this video right here. How does this all come together? And I've actually realized that everyone, I feel like, should watch this video first, and then it tells you everything that goes into all of the modules. So module 8, part 3 is kind of a good starting place, oddly. Then the other things that the National Center has done, which I think are awesome, if you click on this course overview here, it comes up with a Word document where you can literally see exactly the content within all of the modules. Here's a resource of the CEC standards addressed. We have a suggested reading list. It's almost all practice pieces. So a lot of good stuff from like Intervention School and Clinic, a lot of good stuff from Teaching Exceptional Children. These are articles that are meant to be read by anyone. All right, these are not research articles, but they are really good practice-based articles related to the math content. And then the other thing that the NCII has done, let's say you need more supplemental information. So your kids need more practice and place value concepts. There's this, like, if you click on place value concepts, there's videos that go along with this. There's like little practice examples and kind of a deeper dive into how to teach place value.